So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as coordinate system. So I hope you remember in the previous lecture we have discussed about the various topics like different types of projections, map projections, how the map projections are converted, how the map is transformed from 2D, 3D to 2D. So transformation of maps from 3D to 2D. Why we are saying 3D to 2D? Because the real world coordinates which are present on the Earth's surface, that coordinates has to be transferred to the 2D map. So that all conversion we can do through the map transformations, assigning the georeferencing, assigning the latitude and longitude. Now here in today's lecture, we are going to discuss what type of coordinate systems are present which can be assigned to a map. Okay. So let us start this lecture today. So in this lecture, we have coordinate system, plane rectangular system, plane polar coordinate system, geographic coordinate system of Earth, longitude, GPS. Okay, so this all we are going to discuss now. Now coordinate system. So a map is record of the locations of selected real world features in a given geographic space. That means a map is a record of locations. That means when this is the real world, from this real world, map is converted to 2D, right? So this is the map. For example, this is the map. So it is the location of selected real world features in a given geographic space. That means real world features means if you have a road here, so this is the real world feature. This is the real world road. Okay, real world road. So this real world road has to be converted to the map. So what it is done is just it is selected from here and transformed to this map. Okay, so this conversion we say assigning the coordinate system. Okay, assigning the coordinate system. So we are assigning the coordinate system to the map. So location selected real world features in a given geographic space defined using the mathematical concepts of coordinates. So a coordinate is one of the set of numerical value. It's a set of numerical value of x and y. So x and y is what? Longitude and latitude. So longitude and latitude, it is the x and y coordinate. One set of numerical value that fixes the location of a point in a space of a given dimension. Fixes the location means if there is a location here, the same location it has to appear in this map. Okay, same location has to appear in this map. So it fixes the locations. For example, if we have a set of maps 1, 2, 3, 4, 5. So set of maps to 5 adjacent maps. So this 5 adjacent map to be fixed exactly to the location. So what we have to do is we have to assign the coordinates here. So if we are assigning the xy, okay, xy. So all the xy coordinates when you are assigning to this map, then what happens? It will take the exactly real world coordinates to the map. So it will fix the location wherever it has to fit. It will exactly go and fit there. And the second map also, if we assign the actual coordinates here, the second map also will fit to the exact location. So this is how we just try to fix the location. When you are assigning the coordinates, it automatically fixes to its location. So if you are not assigning the coordinates, what happens? The maps elapse one over the other. So this is how if you assign the coordinates, it will just fix to its location. So this is the benefit of assigning the coordinate system, right? So a map is two-dimensional space in which the location of point is fixed by a set of two numerical values. So what is a map? Map is a two-dimensional, that we call it as 2D. So map is 2D where you fix the location of points with set of points of numerical value x and y. Okay, x and y. So what is x here? X is the longitude, y is the latitude. So x and y value when you are assigning to this map, that is a set of numerical values and it is a two-dimensional space. So this two-dimensional space, okay, this is a 2D and here we have three dimensions. This is a 3D of the real world. Okay. Next, digital elevation model is a three-dimensional space in which the location of point is fixed by a set of three numerical values. Now, in map, you have 2D set of x and y map, set of x and y. Whereas, when you talk about this digital elevation model, we call it as DEM. So, when you are showing the DEM, you have a set of x, y, and z. So, you have three coordinates here. Three coordinates will be there. Whereas here you have two coordinates. Okay, two coordinates. So always remember, coordinates is just trying to fix the location with latitude and longitude. Okay. Now three basic types of coordinates are used for fixing the location of geospatial data on maps and GIS databases. So we use three types of coordinate system where we are going to fix the location. First one is plain rectangular coordinate system. So this one is used to convert the 3D information to 2D. So plain rectangular coordinates. Next is plain polar coordinates. So here we have geographic coordinates. So three types of coordinate system we use to fix the location on the map, 2D map. Okay. Now plain rectangular coordinates. So what are plain rectangular coordinates? So a plain rectangular coordinate system for fixing the location of real world feature into two-dimensional space is called as plain rectangular coordinates. So fixing the location. Here we are going to fix the location from 3D world to 2D world. Okay, 2D world. So here we have a rectangular, like in this particular coordinate system, two straight lines intersecting one another at right angles. So this will be like this. Two straight lines will be intersecting. Here we will be finding this is x. This is also x, y, y. The two lines will be intersecting one another at right angles and are used to define the geographic space. So these two lines are called as axis of coordinate system. So these two lines are called as axis of coordinate system. So this is the x-axis, this is the y-axis. Okay, axis of coordinate system, and they define the direction of two families of lines. Now the point of intersection of two lines is called the origin. So point of intersection. So this is the point of intersection. This O is called as origin. This is the origin of the rectangular coordinate system. Okay. So here we have x, y, y. So this is the origin from where it goes up, down. So up here, like latitude, this is longitude. So the horizontal axis OX is called as x-axis. So horizontal axis OX is called as x-axis. Okay. Now the vertical OY is called as y-axis. So this is vertical. This is called as y-axis. Right. Now this is how it looks like. We have quadrants here. First quadrant. So this is your exact intersection here. So this is your axis. Right. Now you have a first quadrant. Then you have a second quadrant, third quadrant, fourth quadrant. Okay. Now you can see here plus x, plus y, minus y. Okay. So here we have minus x and minus y. Here you have plus x and plus y. So these are the four coordinates how the intersection point will take place. So this is your optical axis point, from where these coordinates are intersect. Okay, intersect. Now we have plain polar coordinate system. So this kind of coordinate systems are usually not used for the assigning the coordinate system because it has only one source of location. So the polar coordinate system is a two-dimensional coordinate system. So this is also a two-dimensional coordinate system. So in which each point on a plane is determined by is determined by a distance from the reference point and an angle from the reference directions. So this is how it looks like. So this is the point of axis. From here only all the directions it is diverted. Okay? From OP, then you have a OA. So plane coordinate system is a two-dimensional in which each point on a plane determined by a distance from a reference point. So what is the reference point here? So this is the reference point from where it is just converting the lines to the system. Okay, angle from the reference directions. Now you have a geographic coordinate system of the Earth. What is geographic coordinate system of the Earth? So in order to fix the locations on the Earth's surface, when you want to fix the location on the Earth's surface, suppose this is the Earth's surface, okay. If you want to fix the location, the location, then we use this geographic coordinate system. Spherical coordinate reference system known as the geographic coordinate system. So the Earth is spherical, right? Earth is not round, it's a spherical coordinate system known as the geographic coordinate system has been developed the task into the account of its shape. So this coordinate system make use of network of, that will make use of networks. Suppose the lines will be like this. So networks of latitude and longitude. So it will, this is the equator. Here you have prime meridian. Okay. So it will make use of networks of latitude and longitude. So latitude here, this is the latitude. And this is the longitude. Okay. So it will make use of latitude and longitude to uniquely identify points on the Earth's surface. Okay. So in this coordinate system, the two reference points on the Earth are north and south geographic poles as defined by the 2 points on the surface of the Earth intersected by its axis of rotation. Okay. So this is how the Earth looks like when you assign the geographic coordinate system. Now the reference points on the Earth north and south. So here you have north, here you have south, here you have east, west. Okay. So this will be your latitudes, right? So like this, it will complete the entire latitude and longitude. So in this direction, your entire Earth will be in this direction. Okay. So when you talk about north to south, so here is the equator. Here you have 0 degrees. So 0 to 90 degrees you have to go. Okay. And here 0 to 180 degrees, right? So it will start from here up and down, right? So when it is going up, it is increasing to 90. When it is going down, it is increasing to 90. Okay. So here like 0, you have 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees to up to 90 you have to go. 0, 10, 20, 30, 40, 50, 60, 70 till 90 you have to go. So this is like north to south direction, west to east to west direction. This is how it is represented. So halfway between the 2 poles as defined by 2 points on the surface of the Earth intersected by its axis of rotation. Now this is how it looks like. So this is your north pole, this is your south pole. Now this is the longitude and this is the latitude. Okay. Now here it will go north and south like this. It will be, lines will be calculating like this. Okay. Now projected coordinate system. What is a projected coordinate system? Now this you have seen, these are the 3 points we have seen here, that 3 types of coordinate system we use to convert the 3D information to 2D information. And geographic coordinate system is used only for the spherical Earth. So when you want to convert the spherical Earth coordinate system to the 2D map, then we use this geographic coordinate system to assign the on the map. Now what is projected coordinate system? When you talk about projected coordinate system, so generally we call it as PCS. It's a flat two-dimensional representation of two-dimensional 2D representation of the Earth. Okay, 2D representation of Earth. Unlike geographic coordinate system GCS. GCS is what? Geographic coordinate system. So this geographic coordinate system which represent the locations and the latitude and the longitude on a spherical or ellipsoidal model of the Earth. So that is called as geographic coordinate system. Projected is a flat two-dimensional representation of the Earth, whereas geographic coordinate system we have PCS and GCS. So PCS is used for flat. Remember, PCS is used for flat or 2D, And GCS is used for represent the location of latitude on a spherical. This is used for the 3D, right? 3D model. So PCS use linear units such as meters or feet to define the positions. Now this system is useful for creating maps and performing the spatial analysis because it simplifies the Earth's curved surface into flat plane. Now you understand one thing, you have a Earth, it's a spherical, right? So you have all the features like this in a curved way. All the features like in a curved way. Now this geographic GCS has to be transferred to plane 2D, right? So when you are transferring this to 2D map, the system is useful creating maps and performing the spatial analysis because it simplifies the Earth's curved surface into a flat plane. So here when we are using this GCS, geographic coordinate system, so what it does, it converts the 3D to 2D in a simplifies. 2D simplifies the Earth curved surface, okay, Earth curved surface to the 2D. So this is how we use this GCS, the geographic coordinate system, to convert. Now advantages of projected coordinate system. What are the advantages of projected coordinate system? So first thing is accurate measurements it will give. When you project a image on a map, then you have some advantages that it will give you accurate measurements. What are the accurate measurements? It provide a consistent scale and allow accurate distance and area measurements. So when you are projecting the image from 3D to 2D, what happens? It gives the accurate measurements because it's a mathematical transformation. It's not just converting the map directly to the real world to the 2D map, but it will just help us to convert the mathematical transformation, whatever distances, whatever area, whatever surface is present on the real world feature, it has to be transferred to the 2D map. Okay, so within a map projection defined limits. And the second advantage what we have here is ease of use. So what is ease of use? It simplifies the complex spatial calculations. So when you are projecting the image, when you are using the projected coordinate system or geographic projected coordinate system, that it simplifies the calculation and simplifies the complex spatial calculations and analysis would be more difficult on a curved surface. So compatibility, if you talk about compatibility, commonly used in GIS software and mapping applications facilitating data sharing and integration. Compatibility we can do with the help of this coordinate system. So if you assign a GCS, geographic coordinate system, geographic coordinate to a map, then what happens? It will just help us to use the software mapping the applications, facilitating data sharing and integration will be easier in this coordinate system. Now we have a disadvantage of projected coordinate system. What is the disadvantage of projected coordinate system? Sometimes distortion we face, like all the projections introduce some distortion in a shape, area or direction because they convert a 3 dimension to a 2. So while conversion of 3D to 2D, sometimes what happens? There is a chance of distortion. Okay, there is a chance of distortion, right? Because if it is not properly transformed from 3D world to 2D world, then what happens? There is a chance of distortion. Okay, so convert the 3-dimensional to surface to a 2-dimensional space. So this is the problem with this disadvantage of your projected coordinate system. Now limited scope. What is the limited scope? Some projections are only accurate for small areas. Some of the projections are good or accurate from the small areas and can produce significant error if used in larger regions. So larger regions mean small area if you use for a smaller state. You're using the projection for a state. The accuracy will be maintained. Okay, maintained. But when you are using it for the larger state, okay, when you use for the larger areas, for example, larger areas means when you are projecting it for the world map. Okay, world map, that time you may face some issues related to this projection. Okay, you may face the distortion problems while projecting the large regions. So a geographic coordinate system is a coordinate system that enables every location on Earth to be specified by a set of numbers or letters. So it is, we have a disadvantage here is a geographic coordinate system is a coordinate system that enables every location on the Earth and specified by a set of numbers or letters. So the most common GCS is defined by latitude and longitude, which are based on the spherical or ellipsoidal model of the Earth. Now, what are the some key components of geographic coordinate system if you see? So, geographic coordinate system of key components, we have latitude and longitude. So, latitude measures how, in previous lectures also we have discussed about the latitude and longitude. Latitude measures how far north or south a point is from equator, ranging from minus 90 degrees at south and south pole and to 90 degrees at north pole. So when you talk about the south pole and the north pole, so here you have this equator, here you have prime meridian. Okay, now this is 0 degrees, here 0 degrees. Now from 0 degrees you go to minus 90 degrees south, plus 90 degrees north. So here 10 degrees, 20, 30, 40, 50, 60, 70 till 90 degrees here. Now again you come down here, minus 10 degrees, minus 20 degrees, minus 30 degrees, like that you have to go till here 90 degrees. So it will be measured for how far north and south point is from the equator. So this is the equator, 0 degrees we talk. So from 0 degrees, how far it is from the equator to north and how far it is from the south. So longitude measures how far east or west a point is from the prime meridian. So prime meridian is this 90 degrees here. So how far it is from the, ranging from 180 degrees. So prime meridian 0 degrees to 180 degrees west, 180 degrees west, 0 degrees to 180 degrees east. So how far it is going from east to west. Okay. So this measure is taken care. Okay. So this is prime meridian ranging from minus 180 degrees to plus 180 degrees. So minus 180 degrees to plus 80 degrees, it will be just showing. So datum, what is a datum? A reference model of the Earth. Datum is a reference model of the Earth that defines the size and shape of the ellipsoid. So it's a model of the Earth, we can say. So datum is what? Datum is the model of the Earth, which will help us to define the size, shape of the ellipsoid and the origin and orientation of the coordinate system. So examples include WGS84. WGS84 is the datum. So WGS84 is a world global system. This is the world geographic coordinate system. So this WGS84 is used globally. WGS84 is used for the projection system. This is the coordinate system which is used globally for all types of, all states, all the different countries will be using this commonly for all the countries. So it is a common projection system. It is a common geographic coordinate system which is used by total globe, total world. Now you have a different projection or different coordinate system for the entire world with differently. You have, for example, for India we have Everest, India, Nepal. Like that you have for the different countries also we have their own projection system, like NAD83 for North American datum, and you have ETRS 89 European Terrestrial Reference System. Like this for India we have Everest, India, Nepal. So this is the coordinate system for India. Okay, coordinate system for India. So India will use this the Everest, India, Nepal as a coordinate system as a datum to reference, as a reference model for assigning the coordinates to the real world. Okay, so prime meridian, what is prime meridian? The 0 degree latitude line which passes through the Greenwich, England, and it is the reference point for measuring the longitude. So prime meridian is what? Suppose this is the Earth. So this is the prime meridian. Okay. So measuring the longitude. Now you have equator. What is equator? This is your Earth. So which divides the 0-degree latitude line, which divides the Earth into northern and southern hemisphere. So this is your northern hemisphere. This is your southern hemisphere. Okay. So this is the equator at 0 degrees, which will divide this northern hemisphere. This is the North Pole. Suppose this is your Earth, right? We have an equator here, and this is your prime meridian. Now here you have 0 degrees. Now this is the North Pole. This is the South Pole. Now you have a South Pole, North Pole. Now 0 degrees latitude line. So this is the 0 degrees of latitude line. Now this is how it will be distributed. This is the lines which are formed on the globe. Okay. This is the line how it is formed on the globe. Now here, this is North Pole, this is South Pole. Now this is the line, the thick line what you can see here is, this is equator. Now here the thick line what you can see here is, this is the prime meridian, this is the equator. Now this line divides into northern hemisphere, and below this in the south you have South Pole. This will be divided into southern hemisphere. Okay, this is how the equator is. Now graticule is a network of latitude and longitude lines of map or globe. So these are all graticules. Okay, which will be showing the network of longitude and latitudes. Okay, on the map. Right. So this is about the coordinate system and the projected coordinate system or geographic coordinate system. So I hope you understood that what are the types of coordinate system. So what is basically the coordinate system is assigning the exact location, exact reference point of the real world Earth surface to a 2D map. Okay, converting the 3D location to a 2D map is called as a coordinate system. So that is coordinate system is always in the form of x and y, x coordinate and y coordinate, because once you are converting to 2D, it will be x and y. So when it is once we are talking about the Earth system, it has a x, y and z coordinates. So 3 coordinates in the Earth surface. That coordinates, when it is assigned to a 2D map, that converts to a x and y coordinates. So what are the 3 types of coordinate system we can just assign to the map here is, so the coordinate system what we can assign here is, the first thing is plane rectangular coordinate system, plane polar coordinate system and geographic coordinate system. So these 3 types only we can assign to the map. Now when you talk about this geographic coordinate system, GCS and PCS, the geographic coordinate system is assigning the Earth location to the 2D map. Okay. So projected coordinate system is coordinate system that flat dimensional representation of the Earth surface. This is about the coordinate system we have learned today. Advantages of projected coordinate system also we have learned today. Key components also we have seen that latitude and longitude, and datum. What is the datum? Datum plays a very important role in providing the reference system. It's a reference model which provides the information, which provides the locations and the reference system to the map surface. Prime meridian is the 0 degrees from east to west, right? It will just divide the Earth's surface into west and east. Now equator is dividing the Earth into northern hemisphere to the southern hemisphere, north and south. Okay, graticules are the different networks of lines of latitude and longitude to show on the Earth's surface, which are present on the Earth's surface, and when we convert it to the projection, that is displayed on the map. Okay, so these are the references you can go through to find out more content about it. Manji book you can go through, and the references like links you can go through to find out more information about this coordinate system, and you can even refer this time chain book regarding the GIS for the coordinate system, the reference system, or map transformation, or any kind of projections. If you want to know, just you can go through this. Okay, so that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.